Hey, it's Sarah. Welcome back to my channel. So today we are going over trig functions. So we're still in the pre-calculus review section of my Calculus 1 playlist. So basically the first thing we're going to talk about is just the domain and range of sine, cosine, and tangent. We're not going to go over the domain and range for their reciprocals, cosecant, secant, and cotangent. That was just never something that mattered when I took calculus or when I TA'd calculus, so we're going to stick to this. So for sine and cosine, they're going to have a domain, I was writing the range, a domain of all real numbers and a range from -1 to 1, right? So if you think about how both of them look, right, they're both these like oscillating squiggly lines. So in terms of y, they're going back and forth between -1 and 1. And, you know, this could be the graph of sine or cosine, depending on where you put the y-axis. And then in terms of x, they're covering all real numbers. Another important thing to note about what the range means is that for both sine and cosine, we have this property that becomes important. The sine of any x is going to be bounded between -1 and 1. We could also write that this way. I'll just write it this way for cosine, that the absolute value of cosine is less than or equal to 1, right? So these properties, it's true for both. All right. And then we'll talk about the zeros of sine and cosine. So sine has zeros at the integer multiples of pi, which means that sine x equals 0 when x equals n times pi for some n in the integers, right? And then cosine has its zeros at the integer multiples of pi over 2. So when x equals n times pi over 2 for some integer n. All right. Sine and cosine are both periodic functions, and they both have a period of 2 pi. And so what that's going to mean is that sine of x plus 2 pi equals sine of x, and then cosine of x plus 2 pi equals cosine of x. And then we'll define the tangent function. So the tangent function is just the ratio of sine to cosine. Now, when we talk about the domain and range of tangent, the fact that it's a ratio becomes very important because we can't divide by 0, right? So in order for tangent to be defined, cosine can't be 0. We know that cosine is 0 whenever x is an integer multiple of pi over 2. So the domain of tangent is going to be everywhere that x is not equal to plus or minus pi over 2, plus or minus 3 pi over 2, and so on. All right? And then its range is going to be all real numbers, which makes sense when you look at its graph, right? You have these squiggly lines separated by asymptotes. God, that's a really bad drawing. But, you know, they go on forever in the y direction, even though they are undefined at these asymptotes in the x direction. So we do have a range of all real numbers. Now, the period of tangent is going to be pi, which means that tangent of x plus pi is going to be equal to tangent of x for all x. And then cosecant, secant, and cotangent, those are just the reciprocals. So like I said, I've never needed to know their domain and range, but what you do need to know is that they're reciprocals, and make sure in the future when we do inverses that you don't get these confused with like arc sine and arc cosine. It's a completely different thing, reciprocal versus inverse. We'll get into that later, but yeah. So this is what you need to know for now. All right. So that's all for today. In the next video, we're going to go over my strategy for how to memorize the unit circle. So if you're interested in that, keep watching the playlist and please like and subscribe.